This video provides us an introduction to reference angles. Associated with every non-quadrantal angle in standard position is an acute angle called a reference angle. Now remember that a quadrantal angle is one that falls on either the x or the y axis. So we're saying that any angle that doesn't fall right on the x or the y axis is going to have a reference angle. A reference angle for some angle theta, which is sometimes written theta prime. Honestly, I don't ever use that notation. This is the positive acute angle made by the terminal side of theta and the x-axis. So basically, wherever your angle is, whichever quadrant you're in, you're going to drop a perpendicular to the x-axis, always the x-axis, creating a right triangle, and then your reference angle is whatever the acute angle is inside that right triangle adjacent to the origin. So in quadrant 1, it would be, this angle right here is our reference angle. Our next example, our angle theta is in quadrant 2, so I'm going to drop a perpendicular to the x-axis, creating a right triangle. And our reference angle is this angle here, inside the triangle, adjacent to the origin. In quadrant 3, we have our angle theta. We're going to drop a perpendicular to the x-axis, creating a right triangle. And the reference angle is going to be the angle inside the triangle adjacent to the origin. One more time happening here in the fourth quadrant. Here's the terminal side of our angle. I drop a perpendicular to the x-axis, creating a right triangle, and the reference angle is the angle inside the triangle adjacent to the origin. Please note that you're always dropping that perpendicular to the x-axis and never the y-axis. So let's practice finding some reference angles for each angle. Well, I can't find the reference angle for 270 degrees because that falls on the y-axis. So here, let's make this 170 degrees. I'm going to start by drawing the picture. 0 degrees, 90 degrees, 180, 270. So that angle of 170 degrees is going to be in quadrant 2. I'm going to drop a perpendicular to the x-axis, creating a right triangle, and my reference angle is going to be this angle right here. Well, we've got this straight line here that we know totals 180 degrees. If this portion is 170 degrees, then that leaves only 10 degrees left to be our reference angle. So our reference angle in this example is going to be 10 degrees. Let's try another one. Next we have 49 degrees. This angle will be in quadrant 1. I'm going to drop a perpendicular to the x-axis, and then our reference angle is going to be the angle inside our triangle adjacent to our origin. Well, you'll notice that that's going to be 49 degrees. It is true that in quadrant 1, your reference angle is always going to be whatever your angle theta is. Because it's kind of like when we drop that perpendicular around where we build the triangle around that angle theta. So our reference angle, 49 degrees. All right, one more. 347 degrees. And remember that this 0 degrees could also be thought of as 360 degrees. Our angle, 347, is going to be in our fourth quadrant. We're going to drop a perpendicular down to the x-axis, creating a right triangle, and our reference angle is going to be this angle inside of our triangle. Well, notice that one complete rotation is 360 degrees. And we've gone most of that, but not quite all of that. Right? We've gone 347 degrees. So we need to figure out how much would complete the rotation all the way around 360 degrees, and that'll give our reference angle. So we're going to do 360 minus 347, and that's going to give us our reference angle of 13 degrees.